Okay, in this video I'm going to be doing some distance problems from section 1.1 in Sullivan's Precalculus, and this is a screenshot of the PDF textbook that I have of Sullivan's Precalculus. So I'm just going to do some of these. I'm not going to do all of these, don't worry. Yeah, I'll skip around and we'll do a few. We'll do quite a few. Enough practice to really get you to learn the distance formula and how to use it. So, it says find the distance P1, P2 between the points P1 and P2. I'm going to do the first one, 17. That was really bad. 17. So, 17. We have a point. Okay, so P1 is at the origin, 0, 0. So this is going to be really easy. P2 is 2, 1. So let me just plug it into the distance formula so you can see how easy this is going to be. So x2 minus x1, we'll just say this is all x2, y2. We'll do that first. So 2 minus 0 squared plus 1 minus 0 squared. See how easy this is going to be? Square root, it's just, 2 squared plus 1 squared, which is 2 squared is 4, 1 squared is 1, plus 1. So the distance between these 2 points is root 5, square root 5. Okay, let me do now, enough with the origin stuff. Let me do 19. Okay, I'm going to erase all of this. Cool, I can erase the picture. Alright, 19, oops, that's an R. P2 is equal to negative 2, 2. And P1 is equal to 1, 1. This won't be too bad. So the distance formula says, we'll say this is x2, we'll say this is x1, we'll say this is y2, and this is y1. So, negative 2 minus 1 squared plus y2 minus y1, so 2 minus 1 squared. That's equal to, simplify, so negative 2 minus negative 1. You could also think of this as negative 2 plus negative 1. That's negative 3 squared plus 2 minus 1 is 1. 1 squared is 1. Just going to write that. And then this is square root now. Negative 3 squared is negative 3 times negative 3, which is 9. Okay, so 9 plus 1. This turns out to be the square root of 10. So, did I write the answer for this one? I forget what it was. Whatever. This is, I should write it on the page. The answer to this is square root 10. Okay. Let me do now one without a graph. That's too easy. Too easy. Okay, let's do 21. So 21, P1 is equal to 3, comma, negative 4. P2 is equal to 5, 4. Okay, so let's say this is x2, this is y2, this is x1, this is y1. So distance formula says square root of x2 minus x1, so 5 minus 3 squared plus y2 minus y1 squared. So 4 minus negative 4 squared. So this turns out to be 5 minus 3 is 2 plus 4 minus negative 4 is the same thing as 4 plus positive 4. So 4 plus 4 is 8. Oh, wow. Square root 2 squared is 4 plus 8 squared, 64. So it's the square root of 68. I wonder what that is in decimal form. So I'm plugging it into my calculator. Square root of 68, 8.24. So it's about 8.24 I'll just say 8.246. I'll still write square root 68. Okay, I think you get the gist of how to do it for the rest of these, but you might be looking at 27 and 28 and be like, what the heck? Why are there variables in there? And it's not too hard, so I'll do one of those for you. So let me do 27. So 27 I'm doing. It says P1 is equal to AB, not numbers, some random variable, in 0, 0. Well, the distance formula, let's just say that this is x2, and this is y2, and this is x1, and this is y1, and it doesn't matter. This could be x1 and y1, this could be x2 and y2, but I don't know, I just randomly chose this to be x2 and y2. So distance formula says, this will be the last one we're doing, because I don't want this video to go on too long. x2, so a minus 0 squared plus b minus 0 squared, because this is x2 minus x1, y2 minus y1. This turns into square root a squared plus b squared. This should kind of sound familiar, because when you square, let's just replace d with c really quick. If you square both sides of this, okay, if you square this and you square this, well, the square here cancels out with the square root symbol over a squared plus b squared, and you're gonna get dun da da da, c squared is equal to a squared plus b squared. And that's the Pythagorean theorem. When I first introduced the distance formula in my first video, my second video for pre-calculus tutorials, I said that the distance formula is just another form of the Pythagorean theorem. And by doing this activity, you actually I kind of proved that. Even though this is actually d is equal to the square root a squared plus b squared, that's the distance of here, you can clearly see how the Pythagorean theorem is involved when you do it like this, when you replace d with c. So the answer to this is the distance between them is square root a squared plus b squared. And that's the answer, because we don't know. So that's it for the distance exercises. The next video I'll do midpoint exercises and maybe a combination of both.